Today we're going to be talking about quadratics. It would be chapter 1, section 5. And quadratics are basically anything where you have the highest degree of your polynomial is squared. So in general, anything that's a quadratic would be of the form ax squared plus bx plus c. Okay, and I know you've seen this before. And what they're saying here is that quadratics are transformations of the x squared function. We're going to basically always have the shape of a parabola. And just in case you forgot what that looks like, this is the shape of a parabola. Okay, so let's do an example. A backyard farmer wants to enclose a rectangular space for a new garden. And what you always want to do whenever you have word problems is you really want to draw a picture. So let's have a rectangular space for a new garden. Okay. She has purchased 80 feet of wire fencing to enclose 3 sides. Okay, the 4th side will be against the backyard fence. So basically, there's going to be a fence here. And we're only going to enclose these 3 sides. And we have 80 feet of wire fence. 80 feet, I'll just put a fencing. Okay? And the more I can draw and the more I can write, the less times I have to read this question. Okay? So let's just read it one more time just to make sure we've gotten everything that we've been given so far. A backyard farmer wants to enclose a rectangular space for a new garden. She has purchased 80 feet of wire fencing to enclose 3 sides. Perfect. And we'll put the 4th side against the backyard fence. Find a formula for the area. So we want the area enclosed by the fence if the sides, so our sides of the fencing are perpendicular to the existing fence, have length L. So we can say this is L, this is L, and perpendicular just means that there's a corner, like an actual corner, okay? And we also have whatever this length is. Let's call this width, okay? And if we add up 2L plus W, I have 80 feet, right? That's if I add the length of each side and the width of the garden, that's what I'm going to use my 80 feet of fencing for, okay? And also, we know one more thing, and this is called, we could call this the perimeter, because it's around the outside. We also want to find the formula for the area, and the area is length times width, always, okay? Now, what do? L times W equals area. And we're going to get area in terms of L. I also know that from this equation, W is going to equal 80, and I'm just going to subtract 2L from both sides, so I can say minus 2L. And then I know that the area as a function of length is going to be L times 80, minus 2L. I distribute that L. I get 80L minus 2L squared. So I can say, if I write it in standard form, which is descending order, this would be minus 2L squared plus 80L. Now, forms of quadratic functions. So in standard form, which is what I said, we put this in as standard form. Notice that what you have is you have a function and you have the ax squared plus bx plus c is in descending order. That's called standard form. Transformation form, also called the vertex form. So this is also called vertex form. We call it vertex form because we know that the vertex is going to be HK. So if we have something in this form, HK is the vertex, which is the same as saying the turning point. So even if we have a function that looks like this, wherever it turns, this is the vertex. All right, so now it says, write an equation for the quadratic graph below as a transformation of f of x equals x squared. Well, there's a few things we know. First, we know the easiest way for us to write this would be in vertex form, which is f of x is equal to a times x minus h squared plus k, again, where hk is the vertex. So here's my vertex. Since I know that, I know hk, which is -2, -3. So now we can write f of x is equal to a times x plus 2, because it's minus 2 or plus 2 squared minus 3. And the only thing we don't know at this moment is we don't know a. How do we find a? We need to pick a point on the graph that hits the grid at a certain point. And I see right here a nice, easy point. Okay, so that point is x equals 0, y equals -1. So now I can plug those values in for x and y, and I can solve for a. Let's do it in a new color. So we have -1, because that's f of x is the same as y, is equal to a times 0 plus 2 squared minus 3 minus 1 is equal to a times 2 squared is 4 minus 3. I add 3 to both sides. This becomes 2a. The -3 and +3 will cancel. We can say this is 4a. So what do I have? I have 4a equals 2, a equals 2/4, which equals 1/2. So my final answer would be f of x equals 1/2 times x plus 2 squared minus 3. And that's basically how we find an equation for a graph that's quadratic. Okay? Not too bad, right? Okay, so intercepts. As with any function, we can find vertical intercepts of a quadratic by evaluating the function at an input of 0. New information. So when x equals 0, we will find our vertical intercept, right? Anytime x equals 0 or the horizontal equals 0, we're going to be on our vertical. Notice that depending upon the location of the graph, we might have 0, 1, or 2 horizontal intercepts. Obviously, this has 0, this has 1, and this has 2. How will you know what you have? Well, notice that the standard form of a quadratic, the constant term c, reveals the vertical intercept of the graph. So what we're saying here is, since we know x equals 0, we plug in 0 for x, 0 for x, 0 for x. And what do we find out? We find out that y is always going to be equal to our c value when we have ax squared plus bx plus c. So the vertical intercept is really pretty easy. Okay, horizontal, a little less simple. So if I want to find the vertical and horizontal intercepts for this quadratic equation, well, let's do vertical first, because just like I said, vertical is always easy. So I would say f of 0 is equal to 3 times 0 squared plus 5 times 0 minus 2. This is 0, this is 0. So we know that our vertical, and you can call it y-intercept, our vertical or our y-intercept is equal to, well, what did we do? We plugged in 0 for x, and we got -2. So it's that simple for vertical. Horizontal, a little less simple. So there's a few ways that you can do, you can find your horizontal intercepts, because really we're looking for when y equals 0. Remember, when we look at any kind of parabola, here, x equals 0, and here, y equals 0. So now what I have is 0 equals 3x squared plus 5x minus 2. And if you know how to factor, that's always the best way to start. So I'm gonna, because this has a leading term that's not a leading coefficient that's not 1, it makes it a little more difficult to factor, but I'll show you how to do it. You can also use a quadratic formula, but let's do it. Let me show you how to factor in case you would like to learn. So first, always step 1 is find the greatest common factor. And what I'm asking for is, do we have anything that is in common between these 3 terms? So there's no number that I can divide all 3 of those numbers by without getting a fraction. And x is not common to all of them. So we have a GCF that's really just equal to 1. Our second step is usually the hardest for most people. What I want to do, this is called the AC method. I want to find 2 numbers, and I usually call them m and n. They can be called anything. They're just 2 numbers, and I don't know what they are, so I need letters to represent that, right? So I would say that, sorry about that. So I would say that m times n has to equal a times c. And here my a is 3 and my c is -2. So this would equal 3 times -2, which equals -6. And if I add those two numbers together, which I do not know, they have to equal b, and b here is equal to 5. So if you know the numbers, then you're ready to go. If you don't, if it's a little harder than this, I'll just show you what to do. I usually make a little table. This is m, this is n, and this is m plus n. And I start with my factors of -6. And honestly, don't worry about the negative, just worry about the 6. So two numbers that multiply together to equal 6, 1 and 6, 2 and 3, right? Now I know it is negative, so I can make either one of them I can make either m or n negative. Let's make m negative and add them together. Ah, perfect. We can see that if m is equal to -1 and n is equal to 5, they add together to give me 5, which is what I needed, right? So third step, I'm going to take my first term, 3x squared, and my last term, -2, and I'm going to break this 5x into these two numbers. So I can say -x plus 6x. That equals 5x, which is what we started with. So you can see that, hopefully you can notice that this is equal to our original value. Now I factor by grouping. So what do? I group the first two numbers together. Always put a plus between them. I group the second two numbers together. Okay. Hold on a second. Let me see if I'm gonna move all this down. Okay. Okay, so now I've grouped them and I look for in each group, I look for my greatest common factor. So here it would be x, and I would multiply that by 3x minus 1. I'm going to say plus, and in my second group, my greatest common factor is 2. And if I factor out a 2 or divide each term by 2, I get 3x minus 1. Perfect. Notice 3x minus 1 is in both terms. So what I'm going to do is I'm going to factor out this 3x squared minus, 3x minus 1. So to get my first term, I'm going to multiply by x, right? This gives me x times 3x minus 1. And then my second term, I have to add 2. So basically, you can see that we have this 3x minus 1 in common, and then what's left over is this x plus 2, and this is the original equation in factored form. I can say this has to equal 0 because I want to find my horizontal or x-intercept, and I have to set y equal to 0. And then once I have this, that means that either 3x minus 1 equals 0 or x plus 2 equals 0. So we don't need the parentheses. So I add 1 to both sides. I get 3x equals 1, divide both sides by 3, and I get x equals 1/3, or I subtract 2 from both sides, and I get x equals -2. So I have, let me write it in another color. X equals 1/3, or x equals 2. Okay, so that is doing it with factoring. Let's do it with the quadratic formula. It should make it a little easier for you guys, unless you're very competent at factoring. As long as my function equals 0, and my original function here is 3x squared plus 5x minus 2. So I have f of x equals 3x squared plus 5x minus 2. And since I'm looking for my horizontal intercepts, I can say this equals 0. As long as it equals 0, I can use the quadratic formula. So let's say x is equal to -b, and b is 5, plus or minus the square root of b, we already said was 5, b squared minus 4 times a times c. C is -2. This whole thing divided by 2 times a. And let's simplify. Let's simplify so we get x equals -5 plus or minus the square root of 25. 4 times 3 is 12. 12 times 2 is 24. I have 2 negatives, so that would be plus 24 divided by 6. That equals -5 plus or minus the square root of 49 divided by 6, which equals -5 plus or minus 7/6. Okay? What does that mean? That means x equals -5 plus 7/6, or x equals -5 minus 7/6. Let's simplify. This is 2/6, which is 1/3. Perfect. That's exactly what we got before. And this is -12 divided by 6, which equals -2. Again, exactly what we got before. So I've done it now, use both factoring, and this is using the quadratic formula. And you will get the same answer. Okay? So when a quadratic is not factorable or hard to factor, we can use the quadratic formula, which I just showed you how to use. And this was a little more difficult of a factor. If you know how to factor this, feel free. A ball is thrown upwards from the top of a 40-foot building at a speed of 80 feet per second. The ball's height above the ground can be modeled by the equation h of t equals -16t squared plus 80t plus 40. And it's asking us, when does the ball hit the ground? H of t equals -16t squared plus 80t plus 40. I don't have to draw a picture. There's no need. What I do have to understand is what is the question? So the question is, when does the ball hit the ground? So if h of t is the ball's height above the ground, then when the ball hits the ground, the height is going to equal 0. So I get 0 equals negative 16 t squared plus 80t plus 40. So I'm going to do this next step. Again, not necessary. If you have a calculator, you can just put this directly into the quadratic formula. I get 0 equals negative 8 times 2t squared minus 10t minus 5. If I multiply that back out, I get my original equation. Perfect. Why would I do that? Well, sometimes you might find that this part here is very easy to factor. And if it is, you could just factor it and not worry about the quadratic formula. In this case, it's not. How do I know? I think about the AC method that we just did, and I say A times C, well, that's 10. 10 can be factored into 1 and 10 and 2 and 5. And neither one of those values will give me a negative 10 for the B if I add or subtract them. So I know this is not factorable. But I can, first step, I can divide both sides by negative 8. And I get 0 equals 2t squared minus 10t minus 5. And now I can just plug this directly into the quadratic formula. Because it equals 0, I can say t is equal to, and over here I'm going to write a equals 2, b equals negative 10, and c equals negative 5. So I have negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. And let's simplify it. We get 10 plus or minus the square root of minus 10 squared is 100. I have two negatives. That's going to multiply together to give me a positive. 4 times 2 is 8. 8 times 5 is 40. So I'll get plus 40 divided by 4. And I can separate this into two fractions. I can say this is 10/4 plus the square root of 140 over 4, or 10/4 minus the square root of 140 over 4. All right. Again, if you have a calculator, you would have probably ended this problem long ago, but I'm going to continue to show you some different things because this is a nice problem for that and let you think about it, okay? So I'm going to simplify this to 5/2 plus, and I want to know if I can simplify the square root of 140. So first thing I'm going to do is I'm going to do a factor tree. So I start with 140 at the top, and then I can say 140 is 2 times 70. 70 is 2 times 35, and 35 is 5 times 7. So 140 is equal to 2 times 2 times 5 times 7. And if I want to take the square root of that, I can say this is the same as the square root of 2 times 2 times the square root of 5 times 7. The square root of 2 times 2 is the square root of 4, which is 2, times the square root of 35. Okay? So now I know that the square root of 140 is 2 times the square root of 35. So I can write it in here as 2 times the square root of 35 over 4. And same here, 5/2 minus 2 times the square root of 35 over 4. All right, so we'll continue. 5/2 plus, well, 2 over 4 is the same as 1 over 2. So I have plus the square root of 35 over 2, or I have 5/2 minus the square root of 35 over 2. Okay, now, before I do anything, I know for sure this is going to be positive, but let's just think about this for 1 second. This is really 2.5 minus square root of 35. Let's just say square root of 36 because it's very close to that. So it's pretty close to the square root of 36, which would be 6. And 6 over 2 is 3. Notice this is going to give me a negative number. Since it's going to give me a negative number, and we never talk about time as a negative value, we really don't have to worry about this, because we're only talking about into the future, right? We're not talking about the past. So I can just rewrite this as 5 plus the square root of 35 divided by 2. This would be my precise, like if anybody said to you, I want to know exactly, I don't want you to round it, then that would be it. Rounded 0.458, and our time is in seconds. So that's how long it's going to take this ball to fall to the ground.